Hey there, folks. It's 3 o'clock and it's Tuesday. That means it's Tech Tuesday. Today's topic, I'm going to be talking about how cable operators are upgrading their infrastructure to be able to compete with fiber. And because of those technology upgrades, a lot of them are really not as worried about fiber as a competitor as they used to be. Be right back. Thanks for joining me. Rick Uzzi here with Tech Tuesday. So I saw this article a while back, came out in February, but I thought this was a really good explainer of DOCSIS 4.0 technology, just kind of what cable operators are doing right now. And, obviously the title is intriguing, fiber versus DOCSIS 4.0, how long will fiber's edge last? So I wanted to walk through this article. I'll explain a lot of things as I'm going through it because some of it may be unfamiliar to folks. So, but you see this is Intel competitor. So let's go through this and I'll explain as we go here. So just read through this. So telcos have been deploying fiber broadband, or telcos that have been deploying fiber broadband are having a moment in the sun, finally reversing years of broadband subscriber losses to the cable companies. But will it last? So what they're talking about there is, broadband came out, started with dial-up, and then telephone companies got into the business with DSL, and they were able to offer faster speeds and kind of always on connections with DSL. And then cable operators got into the game. They started offering cable modem service. At first, it was one-way cable modem service, so you could get pretty good speeds downstream, but upstream you had a telephone wire. You had your telephone service, and the upstream traffic went over the telephone wire, so it was called telco return. Then cable operators got two-way service, and when that happened, their speeds got faster and faster, and DSL always had the issue of distance, where you've got copper wire, kind of your two-pair copper wire, the same thing that you'd have telephone service running over, and doing DSL, without significant upgrades and other kinds of more advanced DSL, VDSL, and other things. Most DSL service, as you get further away from the central office, the speeds go down. So you can have some people near the central office that get pretty good speeds, but even that's limited in most cases with the technology that telcos had out there. So cable operators pretty quickly started getting much, much faster than DSL in the service. And telcos had been suffering with that because, again, twisted pair copper going to every home, that was easy, but fiber was a lot harder. And certainly in the earlier days was very, very expensive to deploy. Fiber costs have come down quite a bit, which is why so many telcos have upgraded good portions of their infrastructure to fiber. But there's lots of areas out there that are still DSL. They tend to be in the areas that are more expensive to serve, fewer customers. So the ROI, it's harder to make sense. The same reason that we have broadband issues in rural areas anyway, right? So that's been the case for a lot of years, and telcos were losing customers to cable operators because they couldn't get their DSL infrastructure upgraded, and there was slower speeds. So that's really what they're talking about there. What has given telcos an edge is fiber broadband's ability to support gigabit and even multi-gigabit speeds bidirectionally. With traditional technology, cable companies can offer gigabit and multi-gigabit speeds, but only in the downstream direction. Upstream speeds sometimes top out at just 20 megabits per second. And that's going to depend on the type of DOCSIS that's deployed. DOCSIS is a standard that Cable Labs came out with years and years ago years ago. I mean, it started with DOCSIS 1, and now we're talking about DOCSIS 4, and it's been a long time, many, many years between there. And with each iteration of DOCSIS, they've done things to help make the speeds higher, both on the upstream and the downstream. DOCSIS 3.1 is the most recently deployed standard out there that a lot of cable operators now are on, and many are moving to DOCSIS 4.0, and we're waiting on certain equipment to be ready to take full advantage of that. But so it depends on where a cable operator is in DOCSIS as to what their speeds are. There's most larger operators are DOCSIS 3.1, so your big major MSOs, they're at least at that, and those are the guys that are going to be moving to DOCSIS 4.0 as quickly as possible. We've got smaller operators. There's some that still may be on DOCSIS 3, and they're going to be suffering from slower speeds than DOCSIS 3.1. DOCSIS 3, what DOCSIS 3.1 added was the ability to bond channels together. So you could have, let's say, multiple channels that you could bond together so that you could have, instead of just a 6 megahertz channel, That all started with video. Yes, you had 6 megahertz video channels, but then they started using broadband, a lot of that spectrum for broadband. But now you could bond these 6 megahertz channels together into multiple channels using something called OFDM. And you could therefore send greater amounts of data down that bonded channel. And then they had OFDMA for bonding channels upstream. So then suddenly you could send more data upstream. So that has helped a lot of cable operators be more competitive, even though they can't get speeds a lot of times as fast as fiber operators, certainly on the upstream, and they can't do the symmetrical. That's helped them be at a point where most subscribers are fine with the service because it's certainly fast enough in most cases. So a lot of cable operators are there. Again, there's some smaller ones that may still be on DOCSIS 3.0 that need to get their plants upgraded to at least 3.1 to be able to compete in this world of fiber. All that's set to change, though. Telecompetitor talked recently with Curtis Nittle, VP of Wired Technologies for Cable Labs, about the technology that's coming soon for cable. Upstream speeds are poised to get a lot faster, maybe not fully symmetrical, but probably fast enough for most consumers. And I would say definitely fast enough for most consumers, because most consumers are not thinking so much about their upstream speeds or even their downstream speeds unless somebody puts it out there in front of them and is making a case that you need this. If a cable operator can provide a gig down, let's say, and a half a gig up, unless, if there's a fiber operator in there and they're advertising gig symmetrical, then maybe a customer might go, well, maybe I should get that. I mean, if they're really interested in having the best, but they wouldn't notice a difference if they got it. And it's kind of a hassle to change. So in most cases, it's not as much of a threat as you might think, because the upstream, everybody's using downstream for the most part. Upstream's gotten a lot more important. We saw that with the pandemic as people were trying to stream, through Zoom calls and at work and school. But still, it doesn't take that much upstream to be able to do that. Now, if somebody was on an old DSL connection and they were like 10 by 1 or something like that, and they had a couple of people in the house trying to stream, that was causing problems. But or if they didn't have broadband really much at all, they had satellite, those were problems. But if somebody had a good cable connection, they weren't having a problem at all streaming. So upstream, while again, it's gotten more important, it's still, nobody really needs, most people don't need a gig down, number one, although it's nice if you have it. And certainly most people don't need a gig up. It's very rare that anybody would need a gig up for what most people do, right? So perhaps of greater concern, it's still a lot easier to upgrade cable hybrid fiber coax, HFC, infrastructure than it is to replace telco copper with fiber. HFC networks use fiber networks from the cable company head end to a node where signals are converted to coax cable for delivery to customer locations. So that's why it's called hybrid fiber coax. So basically, cable networks have evolved over time. Again, DOCSIS 3.1 was a big part of this, forcing this. But really what cable operators want to do is get as much fiber in their network as they could and get that fiber as deep as they can to minimize the amount of coax cable. That's the cable that you plug your TV into, or your set-top box in, the coax portion of it. They want fiber going most of the way. So that's what the HFC is, and they're trying, again, to maximize the amount of fiber that they have in their plant. And it's true here that what they're saying is that it is very difficult for a telephone company that's got DSL, for them to upgrade to fiber. It's almost like deploying fiber in a greenfield location. I mean, they might have some synergies or economies of scale with things that are going on in their DSL plant, where they've got some infrastructure, got the central office close by, they've got maybe rights of way and conduit and those kinds of things that maybe they can reuse for the fiber plant. But for the most part, you're not going to be using your twisted pair wire that you've got going anymore. You've got to do fiber all the way to the home. And that's really where the cost is. The cost is going the last mile, from there. I mean, there's obviously, if you're deploying fiber for the first time through the whole plant, that's different as well, too. So, but it's that last mile that's the kicker. That's why a lot of cable operators would be like, yeah, sure, we're going to upgrade our cable. We're going to stop providing cable modem service and we're going to do fiber to the home. And they're just going to make those upgrades. But the problem is those last mile where you basically rip out the coax and put in fiber, that's really expensive. It's disrupting the customer. You've got new technology at the customer prem. It's very, very different. Same for a fiber operator. If they're going from DSL to fiber, they basically have to deploy fiber throughout their plant. They might have fiber now going out to nodes and things like that, but they've still got that last mile where they've got to get that fiber to the customer. And again, disruptive new technology at the consumer home. So it's very expensive for them to do. So they have to do that to get to fiber. Cable operators can make upgrades in their cable plant, and they don't have to go fiber to the home. They can get the fiber really deep in their plant. They can still use the coax, which is capable of delivering very fast speeds. That's not quite as reliable. I'll talk about that in a bit, but they still can get very good speeds, and it's much less expensive. To give you an example, for a cable operator to, let's say, rip out the coax and go fiber to the home, it could cost them $1,000, $2,000, depending on density of the area, that kind of thing, per home. Whereas if they can do upgrades like this, it might cost them $100 or $200 per subscriber. So it's a big difference in costs. And the telcos have that cost if they are going to be doing that DSL to fiber conversion. To maximize speeds, cable companies will be deploying DOCSIS 4.0, the next generation of the DOCSIS standard. They also will be deploying, and in some cases already have deployed, distributed access architecture. In addition, the cable companies are expanding the amount of spectrum that is available for use within the coax portion of the link and making more of that spectrum available for upstream communications. Here's what we learned from Cable Labs about all of this. And again, Cable Labs is the organization that has developed and maintained the DOCSIS standards. DOCSIS 4.0 and DAA, which is distributed access architecture. It says, when we talked to NITL last month, production silicon supporting the DOCSIS 4.0 standard was expected soon. Cable Labs is getting set to certify devices, and NITL expects to see wide-scale deployments of the technology beginning later this year. So there's going to be some equipment, amplifiers, and I think maybe the CPE, I think, might need to be 4.0 to be able to maybe take advantage of some of these things. I can't recall. Those devices are installed in the node. That would be, oh, I'm sorry, I missed that. So another key upgrade is the use of distributed access architecture, or DAA, which, as NITL explained, involves moving intelligence to the edge using remote PHY and remote MAC-PHY devices. And there's a diagram here in a minute that I will... Actually, there's not a diagram. I will pull up a diagram. I'm going to pull up one now. So I have it here. Not on this right here. It's a this is a slide, so I can't point to it. But you see here, this is an example of distributed access architecture, or DAA. So you've got your head-end facility on the left. You see there you've got your ICAP. I think that's might be integrated, converged cable access platform, I believe is what it is. So that's basically your CMTS, or your cable modem termination system. That's the big piece of hardware that sits in the cable head end that distributes the signals all the way out through the cable network to the customers. And converged cable access platform, the converged means it's video and data. So it's not just serving video, it's not just serving data, it can do both. So you've got that, and you see the centralized access architecture, or ICAP. So again, you've got that CMTS doing both of those in the, and it's a full CMTS sitting in the head end. Then you've got head end optics, hybrid fiber coax, and that tends to be, I think that's analog signal over that fiber. So even though it's fiber, it's not digital fiber. Then you've got an HFC node. So this is a typical HFC node. And then you've got certain number of actives, which would be amplifiers. So you need to amplify that signal as you go further out. And then you've got passives. Those would be like your taps and connectors and those kinds of things that they're just basically, they're not actively doing anything other than they're, like I say, they're a connector. And then you've got the CP, the consumer premises equipment, the cable modem in the consumer's home. So that's kind of the way cable has been, again, with the two-way return, like I talked about since almost the beginning. Then you've got remote PHY, which is, PHY means physical, basically, the physical layer. So there you've got what they're calling a CCAP, not an ICCAP. Maybe, again, that I is integrated. I needed to look that up. I forgot. So you get your CCAP MAC core. So it is part of the CMTS in a sense. It's performing a lot of those functions, including the MAC function. But then you've got digital optics instead of analog optics going out to the node. And then in the node, you've got something called a remote PHY device, or an RPD. And that is the kind of the physical layer that connects the customer. So you've got this digital fiber going all the way to the node, and then hopefully as close as you can to the customer. And then from that, you go out to coax to the customer. And hopefully you don't have very many actives. You're still going to probably have a couple of actives, but maybe what they call node plus two, two nodes basic, or nodes plus two amplifier, I should say, node plus two amplifiers, and then maybe out to the customer. That's your coax portion of the plant over there on the right. You got your passives again, and then your CPE, customer premises equipment. Then you've got remote MAC-PHY, which is, you see there it's got data center instead of your CCAP, because really what then you've got is you still got your cable head end, so to speak, your building and wherever that equipment sits, but it's not a CMTS. You've got more like equipment that is going to be routing that signal, and again, going out digital fiber, so a digital signal out fiber to, again, a node, but in this case, instead of a remote PHY device or RPD, you've got a remote MAC-PHY device or an RMD, and that is really like a little mini CMTS. So it's like taking the big piece of hardware that used to be in the head end, and it's scaled down to fit in one of these remote nodes. Could be hanging on a wire, or it could be in a little green box, but it's basically like it sits in the node, and it's like a little CMTS. So instead of serving a whole huge area with one big CMTS and lots of nodes out there, you've got the data center with doing the routing, then you've got these small CMTSs out in the field in various neighborhoods, let's say, and that is serving the customers. And then again, you're going to may have some number of actives there. You could have 0, depending on how many of these you have out in the field. Maybe you can do it without any amplifiers out there. And then again, everything is still, as in this case, when you look at the right, everything is still coax cable. So what cable operators have been trying to do is reduce the amount of coax that they have in their cable plant by pushing out closer and closer to the customer with either these RPDs, the remote PHY devices, or these RMDs, these remote MAC-PHY devices, or these CMTSs that are closer to the end user customer. And both are being deployed. The remote PHY standard came out first, and a lot of service providers were deploying those. The remote MAC-PHY standard came out later. I think in addition to calling it DAA, it's called Flexible MAC architecture, I think, as part of maybe the DOCSIS 4.0 standard. So it's kind of the same thing, but they have a standard for that now. So more people are looking at that now as another option instead of just the RPDs. And I've got in the description of the video, there is a link to a video that I'd done prior about distributed access architecture and / flexible MAC architecture. So feel free to watch that. So that's what distributed access architecture is. Mentions here, let's see here, between those devices and the hub, we've converted the signal to digital optics in the form of Ethernet, 10 gig Ethernet, or 25 gig Ethernet. So again, that's your digital fiber that you're able to send out to those RPDs or those RMDs. Putting another way, said distributed access architecture is defined by digital optics and RF generation at the edge. So that's one of the reasons that DAA is more reliable, because again, you're having more fiber in your plant, and the RF issues that you have in a cable plant are happening over the C part of the HFC, the coax cable, because that's where you're translating and doing the RF spectrum, going from digital to analog, and the RF kind of spectrum, RF signal. So that's where you have problems, and that's where you need diagnostics tools to be looking at things, and then the fewer miles you have of that, the better. But again, it's really expensive to take out that last mile of coax, so that's why cable operators are doing it this way. But they're increasing the reliability as they push out to the edge. They're increasing the ability to have good performance. They've got the digital signal going all the way out to the node, so it's a good way for them to move ahead and be able to really increase the reliability of their plant, the performance of their plant, the ease of maintenance, because you've got fewer miles to go figure out where the RF problem is. So you can lower your maintenance costs at a much lower cost, like I said, $100, $200 per subscriber versus $1,000 or $2,000 or whatever it might take to do the complete fiber upgrade. It's worth noting that some cable companies have been deploying DAA for several years, as it provides benefits even with current generation DOCSIS 3.1 equipment. And that's true. A lot of operators were exploring this very early, especially the bigger guys, your Comcasts, your Charters, and those. Have been doing DAA for a long time. It's been available. Even the remote MAC-PHY, even though there wasn't a standard, people were deploying that. Again, it's basically just a small CMTS, and some are deploying that as well. Then it talks about splits in here, high splits. There's also mid splits. So this would be adding more spectrum basically to the upstream and the downstream. So you're kind of increasing the amount of spectrum that you're using for your cable plant And as you do that, then you can get more bandwidth down that. So you see here, for years, cable companies relied on no more than 860 megahertz of spectrum within the coax portion of their HFC networks. Increasing that spectrum can boost speed. So they're playing a balancing game here. If they're a cable operator and they're providing video and they're providing data, they've got to use some of those channels for video, and they've got to use some of that for data. Now, what some cable operators have been doing is getting rid of their what they call QAM-based video service, which is the video service that they would run over the coax cable. You know, it's like your typical cable TV. You got a set-top box, coax cable plugs into it, and it's going to read the channels that the video is running over. You hit your little button on your remote, and a picture comes up. That's QAM-based video. A lot of cable operators have been ditching that. They've been replacing it with IPTV, because IPTV can come over the same connection that the data comes over, or the same stream, basically. You want to separate it in some ways, but I guess what I'm saying is you're not having to use the channels in order to do that. So cable operators have been doing that, and they can reclaim those channels, get some of that spectrum. In fact, we offer an IPTV product if you're a cable operator and like, I'd love to do that, but it's too much trouble. Well, we actually make it very easy. We have an IPTV product that you can roll out with minimal equipment, and we handle all the programming. And then again, one of the benefits, besides the fact you don't have to deal with the programming and all that stuff, is you can reclaim a lot of your spectrum there if you get rid of the QAM-based video. So many cable companies are opting to expand the usable spectrum to 1.2 gigahertz or even 1.8 gigahertz from this 860, and to expand the portion of the band used for upstream communications. As they expand spectrum, Charter and some other companies plan to use what Cable Labs calls high splits. With this approach, the amount of spectrum available for upstream bandwidth is greater than in the past, but it's still considerably less than what's available for downstream communications. And that's just the reality of it. I mean, it doesn't make sense to make it even on the upstream and the downstream when the downstream is so much more important. So there's no problem with that, as long as, again, as you're providing enough upstream that 99.9999 whatever percent of your customers, that's all they're ever going to need for now. That's the way to go, is to make sure that you don't want it to be symmetrical if there's no need for that, because then you're wasting spectrum. You're wasting spectrum carving it out for the upstream when really you could use it for the downstream when you're doing it that way. So, for example, Charter says it expects to support speeds of up to 5 gigs downstream using DOCSIS 4.0 modems with 1.2 gigahertz of spectrum in high splits. The company expects to support speeds of up to 10 gigs downstream using DOCSIS 4.0 with 1.8 gigahertz of spectrum. In either case, upstream speeds will be 1 gig. So you can see there the cable operators doing DOCSIS 4.0 and deploying that technology and some high splits here can get service that is more than competitive with what fiber is offering today. And I realize that fiber, as we're talking about this, fiber is future-proof, and it, as much as possible, and it's going to be the way that everybody's going, including cable operators. They understand that, right? But again, the cost of having to do that doesn't make any sense for them, because this is just something that's not needed now. The only issue is that fiber can come out and say, hey, we're offering a 10 gig symmetrical service to you now. And if a customer looks at that and goes, I want the best and the latest, when they could get, let's say, 5 gigs by 1 gig from Charter or whoever the cable operator is there, they could switch. But again, they're not going to notice the difference, because we're talking based on what content we have today, right? Unless they're doing virtual reality or augmented reality, those kinds of things, there might be things there that are not quite yet mainstream that maybe that could make a difference. But right now, it's all about marketing. It's like the days of what was it, dial-up, where you could. Well, it's not that. I can't remember. There was something else back when where it was all about marketing, and it was a checkbox, and if you could check it, then you could have a chance of getting a customer, even though there wasn't that much difference. So there's a chart here, and this is from Charter. It was from their investor meeting. So you see here again, you've got your hub. They got a virtual CMTS in this case, so that would be a piece of like kind of standard off-the-shelf equipment, almost off-the-shelf equipment, running CMTS software. Okay. And then you've got right here, they've got in the node, they've got a couple of different things. They've got 25 gig Ethernet. They got maybe a remote OLT that would be optical line termination, I think it is. So that would be fiber. That would be serving fiber customers. And you've got a DOCSIS 4.0 1.8 gigahertz RPD module, again, a remote PHY device running at 1.8 gigahertz at that higher speed on that high split. And then over here, you've got turns to RF, your RF signal over coax. Again, this is the coax portion. So here's your fiber portion. Again, hybrid fiber coax. Here's your fiber portion of the network. You got your coax portion of the network out here. This is your amp. This is your active, a 1.8 gigahertz amp. And this is some of the equipment that needs to come out to be able to do this. DOCSIS 4.0 supporting 1.8 gigahertz in an amplifier. And then you've got 10 gig out here to the home. Looks like 10 by 1. So this is what they could be doing with DOCSIS 4.0. So it's not available yet at this, but this is coming. And right now what Charter can offer is more than competitive with a fiber operator from the standpoint of it's really all that consumers need if they're happy with the service. I don't mean the speed of the service as much as I mean, is it reliable? Do they like the way they get billed? Do they like customer service when they have to call tech support? That's more what consumers are going to be concerned about when comparing two operators, if they can get the speeds that Charter can offer now over, let's say, a DOCSIS 3.1 network, everything that they've got today. But this is allowing them to go that step further to get even faster on the upstream and even on the downstream there. It's worth noting that Charter's target speeds may not represent the maximum speeds that the technology can support. That's true. I think 10 by 6 is what they're saying. And Cable Labs came out and they called this 10G, and the G being gig, not 10th generation, is 10 gig. So they came out with this 10G initiative before they called it DOCSIS 4.0, and that was to compete on the marketing side with 5G, because 5G there was a lot of buzz about 5G. Everybody was talking about how that was going to kill cable and even fiber, because you could get really fast speeds, gig speeds at your home using just wireless. You didn't need any cables. Well, when 5G came out, and I knew this before, and I did several broadcasts about this, 5G came out, and it was really a lot of buzz because the really, really fast speeds were millimeter wave, and you can only get that if you were in a dense area because you needed to have lots of small cells doing millimeter wave. It's very easily attenuated, can't go through walls, can't go through trees, it's just, you get any rain and you can get rain fade. So 5G, a lot of it was hype. It's still great service. You can get mid-band spectrum and you can get pretty good speeds with 5G from something like T-Mobile or something like that. But on the high-end millimeter wave, it was not as fast. You can't get that unless you're like in an urban area and you want to get 5G. There's lots of customers around. So, but the 10G name came out. So that was 10G, and that was supposed to be 10 gig symmetrical. And I think somebody realized along the way, we're not going to be able to do 10 gig upstream as well, at least not with the current plans for DOCSIS 4.0. So I think they're thinking 10 by 6 as being kind of your max limits there. But that's still very fast. And again, more than enough for years to come, I think, with the kind of content we'd be looking at. One cable operator, Comcast, is making a different choice as it extends spectrum. We'll be using a full duplex approach. I just realized I should have posted another video that I did on DOCSIS 4.0 a while back. It might have been called 10G at the time, but I'll go ahead and post that after this. I'll put it in the description as well. And that explains the whole DOCSIS 4.0 10G thing, because originally there were these two paths, and nobody was sure what they were going to do. There was what they were calling extended spectrum DOCSIS, which is what we were talking about, extending the spectrum out to 1.8 gigahertz and maybe even further to be able to get more spectrum to use. But when you do that, you're not changing the way the signal is going down the line. You're still saying a portion of that spectrum is going to be for downstream, a bigger portion, and then a smaller spectrum, smaller slice of that spectrum is going to be for upstream. But what they were trying to do, or what they are doing, is increasing the amount of spectrum so you can have more spectrum for the downstream and more spectrum for the upstream, but they're still separated. So you got a certain number of channels, so to speak, spectrum for upstream, and then you've got more for downstream. What full duplex does is you're taking that whole slice of spectrum and you're able to send the spectrum, the signal down in both directions over the same slice of spectrum, big slice of spectrum, if that makes sense. So Comcast has been looking at that. A lot of operators didn't want to do that because it looked like in the early days you were going to have to go with a node plus 0 arrangement, which meant you needed to go out fiber all the way to the customer and have no amplifiers between that node and the customer. So that would be node plus 0. Again, there's no actives in between that change from fiber to coax and then the customer. well, these amplifiers are coming out now that can allow, I think, 1 or 2 amplifiers in there and still be able to do full duplex. So I think Comcast has checked that out and tested it. So you see here with a full duplex approach, the total amount of spectrum available within the coax portion of the link will be 1.2 gigahertz. So total spectrum 1.2 gigahertz, but can be used in both directions. The key difference is that a large portion of the spectrum will be available for either upstream or downstream communications, which means that Comcast will be able to offer higher upstream speeds. And in doing this, again, you're not having to allocate a certain amount of the spectrum for upstream and a certain amount for downstream. So you don't need to worry about where the splits are. And you just have the whole spectrum, and then it's duplex. So it's going to go back and forth over that same big slice. And you see here they've got what some of these spectrum splits look like. So you've got, this is the DOCSIS 3.1 what was available. So you've got here up to 1.2 gigahertz, and you can see they've got what they call a low split. And this is really where a lot of service providers are today, is on this low split. In order to maybe take the first step, they need to go to a mid split and increase the amount of spectrum that they have in the upstream here. That's what this green area is. And then you've got here what they're calling the high split in this DOCSIS 3.1 world, and that is going up to 204 megahertz on the upstream. So we've got here, if you can't see that, this is 42 megahertz on the upstream. Then you've got 8.5 megahertz, and then you've got 204 megahertz right here. And then you've got this kind of little exclusion zone here where you need to have your separation between your upstream and your downstream. So you're losing a little bit of spectrum right there as you do that. And then we've got DOCSIS 4.0, where we get into extended spectrum DOCSIS, or the full duplex, full division duplexing, I think, which really is just meaning that you're using that model of having upstream and downstream separated. But again, it's extended. So it's extended out here to, you see, to 1.8 gigahertz. So when you do that, you can significantly increase the amount of upstream that you've got here. So we're going now up to 684 megahertz on the upstream. You've got a bigger zone of spectrum here that you can't use. And then you've got your downstream, where you're going up to, again, 1.8 gigahertz. So you're starting at 834. So you're increasing significantly your upstream spectrum here. So this is what we were just looking at that Charter is planning on doing. So again, significantly increasing. They were showing that they could offer a gig on the upstream and 10 gig on the downstream if they go this route. And then you've got what Comcast is looking at, and a few other operators, again, may be looking at this now. So now you've got full duplex, and they're showing here that they've got upstream, maybe that's exclusive to upstream, 42 megahertz. Then you've got the zone in here where you can't be using that spectrum. Then you've got your full duplex in here where you can use upstream or downstream, and that's from 204 to 684. So this is really all can be used by upstream here, very similar to this. And then they've got an area for, it looks like, exclusively downstream, where you're going from the 684 up to the 1.2, and you're not losing this big chunk here of spectrum because I'm not sure why. I guess they must have some way of keeping this separate where it's not going to interfere with anything. So that is the explanation there of both your splits and then your full duplex right here with what Comcast is doing. Comcast says it's achieved speeds of 6 gig down and 4 gig upstream using full duplex, DOCSIS 4.0 in real-world tests. The company expects to be able to replicate that across a large part of its network without taking fiber deeper into the network beginning later this year. So they don't have to do anything with fiber. As far as going deeper in the network, they'll be able to get those kinds of speeds. It's important to note that the speeds that Charter has been able to achieve do not necessarily represent the speeds that the company plans to offer. The company's not been forthcoming with details there. So while they may be able to do 10 by 1, I don't think there's no reason for them to offer that now, certainly to a subscriber. And even though a fiber operator could do 10 by 10, there's no reason for them to offer that other than to say they have it. And if they say they have it and they can offer it, what you're going to find is it might cost you $200 a month. So if you want it, you can pay for it. But I think, for them to be able to do that, they still want to make sure that they've got, their 100 by 100 plan priced at maybe, I don't know, $40, $50, and maybe a gig plan priced at $60 to $80. And then if they're going to do 10 gig, they got to price that higher. So it's more than likely they're not going to want to give that to every consumer. They don't need it. So it's the same thing there with fiber versus cable. It's also important to note that as with DAA, cable companies already have been expanding spectrum overall and on the upstream And as they do, those moves also provide advantages even with current generation DOCSIS 3.1 equipment. So again, cable operators have been doing this. So what you're finding is that cable operators that have been on DOCSIS 3.1 or have upgraded to DOCSIS 3.1, they're not that concerned about fiber competitors coming in, because if they have a good relationship with the customer at the kind of speeds they can deliver, a fiber operator can come in and say, hey, we do gig symmetrical and these guys don't. And they can try to say other things like, how often does your cable go out? Or are you happy with your end user technical support and this and that? But if the customer's happy, again, it's kind of a hassle to switch. So the only other thing would be price. So if they came in and said, we'll give you a gig for the same price, the consumer might go, well, okay, maybe. But again, do they need to switch? Am I not happy with my speed? So cable operators are finding that with the DOCSIS 3.1 upgrades they've made, that they're sitting pretty well competitively. So for a fiber operator, they would probably, you're not going to see them going into areas where there's a major cable operator that's got DOCSIS 3.1 service, because again, right now they're focusing on where do we need to upgrade our plants, where we have DSL, or where are areas where there's not good broadband. Maybe it's a slow cable modem service, or it's there's no service. That's where they're going to be doing their deployments. Fast upgrades. Other recently announced plans to upgrade its entire Charter recently announced plans to upgrade its entire serving area by 2025. Not everyone will get DOCSIS 4.0. The company plans to do its upgrades in 3 stages with different elements of the technologies we've discussed implemented at each stage. And certainly they're going to be doing this in 3 stages. Well, let's see what it says here further. So as the upgrades are completed, 15% of the company's customers will be able to get speeds of 2 by 1 gigabits per second. So 2 down, 1 up. 50% will be able to get speeds of 5 by 1, and 35% will be able to get speeds of 10 by 1. I don't know if they're saying, I don't know if that's the 3 stages or not. I'm thinking the stages are going to be maybe areas that they think they need to be doing this. So they're going to have the most competitive areas where it's like, we need to do this because there's already a fiber company there, and we need to make sure that we can provide the best speeds available. So that may be what they're talking. And then they will maybe offer these as the 3 plans people can get in those areas. Because what I see happening with Charter and others is that they will be looking at their most vulnerable areas first and doing those. And then over time, they may get to a point where they never hit some of those other areas, and they'll just say, you know what, we're just going to go ahead and slowly overbuild with fiber. It's our last stage, or that maybe that's stage 4. And we'll look at, I'm going to show you some figures here on what cable operators are thinking about as far as when they're going to deploy fiber. So I'm not sure what the 3 stages are. Comcast expects to upgrade its entire customer base to DOCSIS 4.0 by 2025. Again, they'll be doing that in stages, and I'm sure they'll be doing that in areas that are most vulnerable or where they can get the best return on that investment in some form or fashion. For telcos, the process of upgrading existing DSL networks to fiber broadband takes longer, and in some cases, the upgrade to fiber may not be cost effective. They got to do it, though. If they don't, then they're going to be out. Somebody's going to get funds from either BEAD to do that, or T-Mobile's going to come in, may already come in and provide a 5G service, and they'll lose those customers if they don't. They're going to have to do that, but it's very expensive again because they've got to tear out. They don't necessarily tear out the copper wire, but they've got to lay fiber all the way to the customer prem. Charter is targeting $100 per location. So here you go, $100 per location for its upgrade plans. And according to financial analysts at SV Moffett-Nathanson, Comcast is targeting $200 per location. Upgrading DSL networks to fiber is considerably more costly. And again, I would put that, it could be $1,000 or $2,000 per customer, because again, they're having to trench or aerial or however they're going to do that all the way to the end user, and then it's new equipment that they've got to put out there. They've got to touch every subscriber home, where you don't have to do that if you are just upgrading most of the way to the subscriber, which is what cable is doing. Worth noting that when cable companies expand to areas they never served previously, they are deploying fiber broadband, and that is very important to note. So what we're talking about here is for cable operators in existing areas where they have investments in infrastructure, and they can do it for $100, $200. But if they're going into a new area, they're not going to build cable plant there. They are going to go fiber to the home there. It's going to be more expensive than upgrading current infrastructure, but probably not more expensive than putting in a cable plant and trying to go all the way to the home, doing all of this other stuff that they're having to do. So they're certainly going to go fiber to the curb, or fiber to the prem in that case. And as companies like Charter and Comcast pursue projects in unserved and underserved rural areas, projects funded in part through government programs, we'll see them use fiber there too. So again, BEAD is perfect for, let's say, the telco that has DSL infrastructure, but this just doesn't make sense to be able to, there's not a good return on investment to maybe do fiber without getting assistance from the government. So the BEAD program, for example, Broadband Equity Access and Deployment, they should be able to apply for funds to do that. And they should have a foot in the door. If they've already got infrastructure there and they've been providing service and it's been mostly economics that's prevented them from upgrading that, then if they can get over the economic challenge and do that, then they are the best person or entity to be able to go ahead and put fiber in there. That's assuming that they're a good, financially stable operator that provides good service, that is concerned with the customer. Those kinds of things are all intangibles, but are important. We also see them selectively upgrade some of their existing infrastructure to fiber broadband. Nevertheless, their current HFC infrastructure may soon be a lot more competitive than it's been in the last year or two, and it could remain that way for quite some time. So I'd say if they're on DOCSIS 3.1 now, then they're pretty competitive, and they're able to do additional upgrades over DOCSIS 3.1, some of these high splits under the DOCSIS 3.1 model that can make them very competitive. Then DOCSIS 4 only gives them even further ability to extend that spectrum further or do the full duplex thing. So I wanted to also show here some slides. I showed one of these, but what's going to be another one? Where is it? Here? Yeah. So I showed this slide, but let me move on here. So this was in ATX every year or last several years has done something they call the 2050 project survey. And 2050 was kind of when people were saying cable would be gone. Okay, so the hybrid fiber coax model, the HFC model, is going to be gone really for the most part. And then all these cable operators are going to be doing fiber at that point. So that's why they call it 2050 project survey report. And they've done this the last couple of years. And you can see here, they're showing results from the last 3 on a couple of these questions. And I thought these were the most relevant questions to what we're talking about today. So you see here, considering the expense of logistical difficulties associated with fiber builds, what would be the most aggressive time frame for completely replacing your HFC network with all fiber? And again, I can't point to this on this particular slide, but you can see here you've got, back in 2021, 28% were thinking 6 to 10 years. What's that? Oh, the blue is 1 to 5 years. So 11% were thinking 1 to 5 years, 38%, excuse me, in the orange on 2021 were thinking 6 to 10 years. Then you've got 11 to 20 in the purple. So you can see that 13% for 21 to 30 years, and then 10% beyond 30 years. So that would be your 2050 folks and beyond, I guess. And then you've got 2022. So think about changes in 21 and 2022. And there've been a lot of talk about fiber and everybody, we need to do fiber. Fiber's future-proof. All of the federal grants that were coming out were like, okay, we want you to do fiber. We're really want you to do fiber. So they're really focusing on fiber, and for a good reason. If you're going to be building into a new area, you want to be doing fiber, if at all possible, right? But these are existing areas that already probably have, again, could be DOCSIS 3.1, good service. So they would not qualify for BEAD. I mean, if they're providing DOCSIS 3.1 cable modem service, they are a existing provider that is providing reliable broadband service. So, but there was still all this buzz about fiber. We need fiber. So a lot of operators were probably thinking, hey, we need to be doing this. But it's interesting that over time, you see 2022, it increased the amount of people that thought they would be doing it sooner. So you had their 1 to 5 years went up to 16%. You've got 6 to 10 years, that went up to 43%. 11 to 20 years went up to 37%. So you can see all of those went up. The 21 to 30 and the beyond 30 years went down. So a lot of operators said, yeah, we're going to do it sooner than we thought last year. Well, this last report, now you don't necessarily have the same exact operators answering. You probably have a good number of them being the same. But in this last report, it kind of backed down a little bit. So you see, we now went from 16 to 13% on 1 to 5 years. We went from 43% to 37% on 6 to 10 years. And then 11 to 20 years went from 36% to 37%, so it went up a little bit. So you still see some folks now thinking, well, you know what, with DOCSIS 3.1 upgrades that we're doing and DOCSIS 4.0 coming out, we think we don't have to stress out about this as much. So they're really focusing on squeezing the most that they can out of their HFC plant because, again, economically, it makes sense. They're already providing really good speeds. As they get further deep in their plant with fiber, their maintenance costs go down, their reliability goes up, the RF issues go down, the kinds of things that issues you would have over that coax portion. As they reduce amplifiers, reduce these actives, all of those things help improve the service. So they're probably thinking now, it's like, you know what, we can operate on this HFC plant for longer than we thought last year. And again, let's not forget that if they see an opportunity and if they're going to edge out their network somewhere, they're probably going to edge it out with fiber rather than do that as a coax play, because there's nodes now where, again, they can just go out with a fiber node and with a remote OLT in there and then go out and deliver fiber service to that new area as opposed to putting out a CMTS and doing the RF coax thing. Another one that I thought was very interesting here. So this is from part of the report. So it says, interestingly, and despite the aggressive build-out plans by fiber to the home providers, which are fueled by unprecedented amounts of public subsidies, MSOs are growing less fearful of fiber as a long-term threat, according to the latest survey results. And again, let's remind you that the unprecedented amounts of public subsidies are not going to pay for overbuilding a quality cable plant if they're offering service that's over 100 by 20, because it does not count as unserved or underserved. So they don't need to be concerned about that. What they need to be concerned about is if they're providing lousy service and a competitor comes in and takes customers because of that. So somebody's not going to get paid money to go and deliver service in an area that's already getting broadband. How much of a long-term competitive threat do you consider fiber to the home providers? So that was the question asked. And you can see here in 2022 versus 2023. 2022, no threat at all, 3% versus 4% in 2023. Not much of a threat, 16%. That jumped up to 34% in 2023. And then somewhat of a threat was 54% in 2022, and it reduced to 42%. So you can see, and then you've got significant threat went from 27% to 20%. So their anxiety has reduced. I think they're just looking at it more logically now. There was a lot of stuff being thrown at them, and they were probably concerned about fiber operators, but they realize that nobody's going to get paid from the government to overbuild in an area where they're providing good service. Number one, good, reliable broadband service. And number two, the kinds of speeds that they can deliver are more than adequate for customers. So that's the big key, is that if a fiber operator comes in, that fiber operator is going to have to market the service and somehow try to pull customers away from them. And that's not going to be easy. So fiber operators, if they're not there now, they're not going to pay the money to go in and overbuild in an area where you've got a good quality cable operator at this point. So I think that's why. And there's one other thing in here that I thought was very interesting because it applies to something that we help with. So you see here, this is about DOCSIS proactive network maintenance. So again, what cable operators are trying to do is squeeze as much performance out of their cable plant as they can and improve reliability and reduce maintenance costs. So they can do all of these things like upstream splits and whatnot, but they still have that portion of the cable plant that they have to worry about maintaining. It's harder to maintain. It's less reliable. They need good diagnostics for that. And they need to know where they have problems in that last mile or last couple of miles, whatever that segment is. So I'll just read this. So related to the added intelligence issue, and this was about something prior in the report, it says, use of proactive network maintenance or P&M capabilities to reduce network downtime and increase customer satisfaction through improved reliability. When Cable Labs introduced P&M more than a decade ago, it essentially converted every cable modem in an HFC network into a troubleshooting device, an invaluable source of extensive network information that fortified network technicians with a treasure trove of network-related diagnostics information. Based on the results of the following question, posed for the first time in the 2023 survey, a solid majority of MSOs are planning to make better use of P&M-derived information in the future. And it says here, please rank your agreement with the following statement. My company plans to rely more heavily in the future on the diagnostic benefits and capabilities of P&M. So you can see here 23% highly agree with that and 46% agree. So over 50% plan on using DOCSIS P&M, making better use of it, or I'm thinking maybe using it for the first time. 30%, that's the purple, somewhat agree. So you've got only, what is it, 0% highly disagree, and 1%, I guess it is, disagree. So most everybody agrees to some extent, and a lot of them, it's over 50%, highly agree or agree. So what is DOCSIS P&M? So what that does is, like it says here, it can read information from the cable modems and determine how hard they're adjusting their system, how they're adjusting their signal, And then from that, you can display on a map the cable modems that need the most attention, the ones that are being impacted the most maybe by ingress, or you can look and you can see if there's a group of 5 or 10 or more modems that are being impacted by the same impairment, like maybe there's a micro reflection in that RF portion of the network, and you can see on the map where it is, and then you can kind of figure out where to start looking for that. So it all is proactive in the sense that it actually can see these things prior to that impacting a subscriber. So even though you can see there's a really bad micro reflection in this area, and these 10 modems are impacted by it, those 10 modems could be just fine as far as the customer experience, because the cable modem is adjusting its signal to compensate for that. But unfortunately, on an HFC network, it's very different from fiber and digital optics, those kinds of things. On an HFC network, those kinds of things get worse over time. It could be a connector that's got corrosion in it or that's loose, and then as that gets worse over time, then the cable modems eventually can't adjust their signal enough. So you could have one customer that goes down if it's a near home issue, or you could have 10 customers that go down or more if it's maybe a connector on an active or a passive that's feeding a lot of homes. Then that can go down. Plus, it doesn't always happen all at once, because it could be as it gets worse over time, it could be that there's a temperature change, the temperature goes down, or it rains and some moisture gets in and some radial cracks in a cable, and suddenly you've got intermittent issues and customers are calling and you're trying to find it, and you're going out, and basically what they have to do is they have to roll a truck to the home. And then they get a call from somebody else, and they roll the truck to that home. And then they realize, wait a minute, we got calls here, here, and here, and they're all talking about the same thing. And then they got to try to figure out where it is. Well, with the P&M application, you actually see the homes that are being impacted by that, and you can kind of on the map look and see where you need to go look. And you can do that all before the customer calls. That's why that's so important, so that these cable operators can do this maintenance proactively. So you can reduce these unplanned outages. You can reduce ingress in the plant, so you can go see which homes have got maybe loose connectors, or maybe there's a cut in a piece of buried cable, and you can see that home is being impacted by ingress, by noise getting in the upstream plant. You can go correct that, and that improves your upstream signal for everybody that's upstream of that. So these are ways that cable operators can reduce their maintenance costs, because they're not running around all over the place, rolling trucks when the thing's on fire. They can schedule it and say, okay, we're going to be out in this area. Let's go see what's going on at this home. We got a lot of ingress coming in here. We've got something real close to this home that's a problem. It could be a loose connector right at the home there that you need to go look at, versus having to handle all these things, like I say, at the last minute, reactive versus proactive. So I want to make sure you were aware of that, and that you can find out about that on our website. So I'll have the website up here in a minute, but go to zquorum.com, and you can see, if you go to under products and click on pre-equalization analyzer, that's the product, and you will see that we have a microsite up there on that product about everything about DOCSIS proactive network maintenance that you'd want to ever learn is up there. So if you're a cable operator and you've been watching this and you're going, wow, I'm doing all of this other stuff, I need P&M to be able to also further reduce my costs, further improve my stability and the reliability of my network, because that's important. You can do everything you can to reduce the amount of fiber that you have in your plant, but you still got that RF section that you've got to manage and maintain. And if you can attack that and make sure that you can proactively maintain that and reduce customer outages, reduce complaints, improve the signal, or improve the upstream signal on that portion of the plant, then you're going to go even further in being able to compete with a fiber operator who's got fiber all the way to the subscriber. Because again, fiber is where it's at. That's where it's all going. It's just that cable operators, they have a path right now for the foreseeable future to be able to upgrade their cable plants and not have to worry about tearing out all of this coax that they've got in their plant and going fiber to the curb. They'll eventually do that. But for right now, if it's a greenfield area, then they're going to go fiber to those customers. But in their existing plant, unless it's an area that has got just old infrastructure and they need to do more upgrades, they're probably going to go ahead and do a lot of what we've been talking about today. And the PNM thing can help them further increase that. So you see here our phone number and our web address. So if you have interest in our email, so if you have an interest in PNM, reach out to us or check out the website where I mentioned go to pre-equalization analyzer on the products menu. You'll see that if you have an interest in that. So thanks for joining me. Hopefully this answered a lot of questions for you. If you've been wondering what cable operators are doing and how they're going to be, the competitive landscape, how they're going to be upgrading their plant to compete with fiber in certain areas. If you're not subscribed to our video, if you would, click the subscribe button, click the little bell, and you'll be notified when I'm live. And I'm live on some Tuesdays for Tech Tuesday. I'm live every other day for broadband deployment news, so you'll get notified about those, and you can watch then or watch the recording later, or don't watch if it's not a topic you're interested in. If this was helpful, again, if you'd give me a like on the video, I'd appreciate it. I always like to see those likes that, lets me know that it's content that's good for you, so I appreciate that. Thanks for joining me for Tech Tuesday. I will be back tomorrow for broadband deployment news. I will see you then, hopefully. Bye-bye.